Thank you everyone for joining. Brief introduction. I'm Christina. I'm the product lead for Ecosystem Code, and it's very exciting to have these discussions as we progress into the development of this product and also how it can be used in different spaces and across different requirements as well. For today's conversation though, I strongly believe that architectural alignment is among the most important discussions and also a discussion point that is underexplored in the spaces around coding, development, and engineering right now. Because when we talk about what happens to your code base or your team structure or architectural coherence, when you hand the keyboard to artificial intelligence, it's not just something that is confined to the individual in an organization, but also it's something that affects team construction. And these teams tend to be moving fast. So that's something that we really want to bring to the forefront and also to create the space for the usability of ecosystem code at an organizational level to provide a sense of coherence and operability in that space. To begin with, I do want to carve this with something that's been pertinent in the industry at the moment, that's been happening for the past couple of weeks. And this is something that has made headlines and also perfectly frames everything that we are going to talk about today. And so this is around the recent changes that were introduced by Anthropic, which is the company behind Claude, which is one of the most widely used AI coding assistants at the moment. And they introduced a change that quietly impacted the usability of the platform. And this is that during peak weekday hours, what was originally a 5-hour usage session would now burn faster than before, which meant that there weren't necessarily fewer messages or a weekly limit, but the rate at which you consumed your allocated usage accelerated, and deliberately so by design, because the demand for the product had outrun the capacity that they were able to provide. And so the reaction from the industry was immediate. We saw developers flooding online forums to discuss this, and overnight, the users of one of the max plans that Claude offers reported hitting their session limit on a single prompt. And so you're probably wondering, why am I telling this story? Why does AI usage limit crisis belong at a discussion around architectural alignment? And that's because it reveals something deeper than just a capacity problem. So think about what actually happened. We had thousands of development teams across hundreds of companies that had built their workflows around the assumption of a consistent, available, stateless AI assistant. They hadn't documented what that assistant knew about their system. They had the context needed to generate useful output. Every session started fresh. Every team had a slightly different implicit understanding of their own architecture, and they stored nowhere except in that AI's context window, which reset every 5 hours. And so when the limit hit, it wasn't just inconvenient. So for teams that were relying on AI-generated code without a persistent structural reference, it was the moment that the house of cards became visible. The code was inconsistent, the schemas had drifted, the APIs were undocumented, and this is something that had quite a number of questions in this space. And so that is one of the problems we want to solve today, not the capacity limit, but rather the structural fragility that the capacity limit exposed. And before we jump into that, allow me to just map where we are going to be going in the discussion and the core topics that we want to discuss and how they all connect. We're going to be talking about how you define quality within an AI-assisted organization, the artificial intelligence models you use in order to generate consistently, how you choose the right data topology for your systems, how feedback loops actually work across departments, how to consolidate data and orchestrate complex systems, and finally, the bigger picture of what AI-assisted work means for organizational coherence in the future. And these aren't just isolated topics. These are layers, and each one builds on the last. So hopefully we can stay together on this and land towards the end of this as well. And for this, I think it's important that we name the specific failure mode we are designing against. And I want to be quite precise about this because vague problem statements tend to lead to vague solutions. So when multiple teams in the same organization are using AI to generate code, what usually happens is this. We have each team's AI assistant is working from a different implicit understanding of the system. Team A has been using system for 3 months and it has trained their context window to understand their domain model, whereas Team B could be using a completely different model with a slightly different mental model. And you can have Team C that has a senior engineer senior who knows the architecture deeply, but when they're on leave, the junior is prompting the AI with vague requirements and getting vague code back. And so what is the operational structure that causes these failure modes to accumulate over time? Firstly, what we tend to see is that there is no architectural visibility. We have API routes that drift between iterations, not because a bad decision was made, but because the AI doesn't know what routes already exist. Database schemas mutate unexpectedly, documentation diverges from implementation because the code was generated without reference to the documented architecture. And the really insidious part of all of this is that this drift is invisible until it compounds into a crisis. Secondly, what we tend to see is the regeneration trap. And here what tends to happen is every new AI session starts from scratch. If your team gets hit by the kind of capacity limit we just talked about, or if a developer leaves, all of that implicit structural knowledge evaporates. The next session regenerates with no memory of what came before. And so this creates output inconsistency that compounds over time. You might generate a React component today and a slightly different version of the same component next Tuesday because the context was different. Thirdly, we have architectural entropy, and this is the slow accumulation of all of these that we've discussed so far, where we have inconsistent code bases, teams that can't read each other's code, refactoring becomes exponentially harder over time, technical debt accumulates invisibly across squads until a new developer joins and asks, why does this work the way that it does? And nobody on the team can answer that. And so we see that AI development without a persistent structural reference introduces entropy at the architectural level and not just at the code level. And so the fix isn't just better prompting. The fix isn't a better AI model. The fix is rather externalizing your architecture so that every team's AI is generating from the same shared understanding of the system. And that shared understanding has a name, and we tend to call it the deterministic spine. And I want us to take a deeper dive into to understand the core of this concept, but also its functionality and what it can provide. And the premise is simple. If multiple teams are going to use AI to generate code independently, they need a single shared reference to generate from, which could be advantageously a live versioned queryable structural reference that your AI toolchain can actually ingest and act on. And the deterministic spine has 6 layers, and you can think of them as the cross-section of any reasonably complex system. There are the foundations, which consist of structure and service boundaries. And so before any API is designed, before any database is modeled, you need clarity on what services exist and where the lines between them are. And this is where domain-driven design meets AI. If the AI doesn't know where your domain boundaries exist, it will generate code that crosses them freely, creating coupling that's painful to undo. From then on, we have API design, and these consist of the endpoint definitions, the authentication, the permissions, and this layer governs how services talk to each other and how clients interact with your system. So if teams A generates an endpoint that team B doesn't know exists, you get a redundancy at best, and this conflict can worsen over time. From there, we have databases, which consist of schemas, relational structures, data modeling decisions. And this is often where the most dangerous drift happens. An AI that doesn't know your existing schema will happily generate a new table from a concept that already exists under a different name in table 3 schemas over in a different department. From there, we have caching layers. So these are your performance decisions. Which data is cached? Which is invalidated and under what conditions? And so these decisions are all architectural. They cannot be regenerated arbitrarily without understanding the read-write patterns of the whole system. From there, we have big data and processing, and this consists of the pipeline architecture and the data flow. So if you have an analytical workload or event streams or machine learning pipelines, you want these to be in a structural reference. Otherwise, your AI will generate for the happy path and ignore the scale path. As well is infrastructure, which consists of the production deployment, the cloud patterns, the environment configuration, right? Where your artificial intelligence model shouldn't be guessing whether you're deploying to Kubernetes or if you want it to be serverless. That decision should be in the reference. And so here's the critical mechanism that makes this work, and that is progressive disclosure, where the deterministic spine doesn't feed everything to every AI assistant at once. That would overwhelm the context window and produce worse results than no context at all. Instead, you want to have the relevant component exposed to the AI generation at the relevant time. So for example, if you're working on a payment service, the AI needs to see the payment services domain models, the APIs, its schema at the right time, not the notification system, not the analytics pipeline. You want to have the right context at the right time with the right precision. And so this is what moves AI generation from probabilistic guessing to deterministic traceable output. And the same structural reference, consistency that is applied over time produces the same architectural decisions regardless of which team is running the generation. From there, we move on to local first architecture patterns. And I want to spend a couple of minutes just understanding what we mean by architectural topology, because the decision you make here, whether local first, client server, or hybrid, has profound implications for how your AI generated system will behave in production. And this is one of the decisions that your deterministic spine must encode explicitly. So for example, for local first systems, these tend to have offline capabilities by default, where read and writes happen locally. They use your own data. And this model is increasingly interesting for AI native applications, such as developer environments or collaborative tools or edge AI agents, because it removes the network dependency from the heart. And so the trade-offs are real, right? You tend to see sync conflict, or resolution tends to be complex, or schema evolution requires careful planning. And from there, we also have client server, which is an architectural approach that most enterprise systems are built on. And for good reason. You tend to have a single source of truth, a centralized auth path, you have audit logs, you have easier schema migrations. And so you know where the data is. The trade-offs are network dependency, and the fact that your server costs scale linearly with your user base are also things that need to be considered. But also among that, we have a hybrid approach. And this is increasingly used where sophisticated systems are landing, where there's a local resilience with server sync. So you get the best of both worlds in terms of resilience and collaboration, where the cost is architectural complexity. You're now managing two consistency models simultaneously, and the surface area for drift is higher. So this matters for what we're talking about today, because the topology decision is architectural. It affects your design. It affects your caching strategy. If this decision isn't encoded in your deterministic spine, every AI session makes its own assumption. You might get a local first schema from one generation and a service-centric one from the next. And so this inconsistency accumulates invisibly and until it becomes a production incident. So what we've developed to mitigate this are ecosystem codes, UML models that encode these decisions upfront, and the generated scaffold reflects the topology you choose and not the topology that the AI has guessed for itself. From there, we have the concept of backpropagation, and this is something that is pertinent in the space of machine learning, but I would like to introduce it in this discussion as well as a model for thinking about organizational alignment that can be quite useful and something that we can transform. So in what we can understand backpropagation as is that in a neural network, backpropagation is the mechanism by which errors are distributed backwards through the network to update the weights that cause them. So you run a forward pass, you get an output, you measure the error between that output and what you wanted, and you send a signal backwards that adjusts every weight that contributed to that error proportionally based on how much. You can think of applying that to an organization where, for example, you have your different departments such as engineering, product, data, and operations, and these are the layers of the network. Each one is producing outputs, whether it's code, whether it's features, whether it's pipelines, whether it's deployments, and those outputs feed into a result, whether this is a business outcome, a customer experience, a quarterly number. And when there's an error, when the result isn't what you wanted, the question is, how does that signal propagate back to the layers that caused it? And so in most organizations, this doesn't happen, or it tends to propagate slowly through politics and retrospectives. And so by the time the signal reaches the engineering team that made the architectural decision that caused the production incident 6 months later, and so what we want instead is a signal aggregation layer, which is a shared set of metrics and architectural governance signals that sit between the departments and the decision-making layer, can remove the requirement for a committee that needs to review every decision. You have a live queryable model of system help that makes the errors signals fast, clear, and traceable. And another component of this is decision layers, right? Where architectural governance happens. And this can be understood as a governance framework where the right architecture is the path of least resistance, because the deterministic spine makes it harder to deviate than it is to comply. And so the interdepartmental alignment piece matters here. So when you have have engineering, product, data, and operations signals and requests that are all flowing at the same aggregation layer, you start to see something remarkable, which is net yield becomes visible, not departmental yield, but rather organizational yield. The system as a whole can optimize because the error signal is clear enough to propagate back to the right layer. So the architectural governance model, which consists of blueprint libraries, shared UML references, pre-generation validation, is the mechanism that makes this possible at that engineering level. And it's the weight update function of the organization's nervous system. And from there, we want to move on to how this can be embedded into the system to provide or allow for that orchestration and data consolidation. And I want us to talk about what it looks like to actually coordinate multiple AI-assisted teams at a systems level, and how data consolidation across departments enables the kind of architectural governance we've just described. So for system orchestration in a multi-team AI system, there's a specific challenge that we didn't see existing before. This is where your AI tool chain needs to know about the whole system without being given the whole system at once. And this is the orchestration problem, where we see too little context and the AI generates incorrectly. And you could also have, on the other hand, too much context and you blow the token window and performance degrades over time. So what the blueprint library does is that it provides an answer to this. It's the single orchestration contract, which provides the document that defines what every service exposes, what every API accepts, what every schema looks like. And so when an agent API is ready, it means the context can be injected programmatically at generation time and with exactly the right scope. And what UML sequence diagrams in ecosystem code do specifically here is they allow you to define inter-service message flows. So which service calls which, in what order, with what payload. And so this isn't documentation for its own sake. It's specification that allows AI-generated services to integrate correctly with each other without a human manually wiring them each time after the fact. On the data consolidation side, the challenge is that different departments generate signals in different formats. These tend to be stored in different systems with different cadences as well. So you can have engineering that has CI/CD metrics and code generation usage data and schema versions in its own system. And you can have a product team that has feature flags and user stories in a backlog state. Or you could also have data that has pipeline health and model performance in a completely different system as well. And so the goal is to bring these into a shared relational model, not one that is centralized where all the data is in one warehouse, but to create the joins, to be able to ask that when this schema was versioned or when it was changed, what was the incident rate in the following week, right? When this feature flag was enabled, how did code generation usage change? These are the questions that make architectural decisions traceable to business outcomes. And that relational visibility, which is anchored to the same architectural model that governs generation, is the foundation of AI at scale governance. You're not managing the AI, you're managing the context the AI operates within, and you're measuring the outcomes that the context provides as well. What all of this means for the future of work, because the technical patterns we've discussed so far aren't just optimizations, they're responses to a structural disruption that's already underway in the industry. We see that the coder as we've known them is rapidly becoming the architect, right? The developer role is shifting. AI absorbs repetitive code generation faster than most, and so the value of a developer is increasingly in their judgment, their ability to define the right context, ask the right questions, and therefore make the right architectural decisions. And so what ecosystem codes tool provide is that shift, right? It's designed for developers who think architecturally, who want to move from writing boilerplate to governing the system that generates. And for the applicability of such a system within an organization, it provides a level of scale and development that is compounded, honestly, compared to what we've known before. And so disruption is already structural. What we've seen with Anthropic's story that we opened with isn't just an edge case, but rather it can be seen as something that is a preview. Fast-moving teams that haven't built that structural coherence into into their AI workflows will feel this acutely as AI usage limits tighten, as models change, as context windows evolve. And so we see that the teams that win are the ones that have externalized their architecture so that any model, any tool, any session can generate consistently from a stable reference. Honestly, emphasize governance without gatekeeping, right? The old model of architectural governance, which consisted of having a central review board, a senior architect who approves every pull request, it doesn't scale to AI-assisted development philosophy. And so the winning model is structural. Make the right architecture the easiest path. Blueprint libraries, pre-generation validation, shared UML references, these make compliance effortless and deviation visible. And that's governance that doesn't just slow down. And from this, we are able to create an environment for organizations that survive. Well, these will be the ones that embed architectural alignment into their AI tool chains as a first-class concern and not something that is separate from the governance process that runs parallel to development, but as the scaffolding that development happens within. And so the organizations doing this well right now are going to have that compounding advantage over the next 2 or 3 years that will be very hard to close. I know that one area of concern for a lot of us in this space is on delivery time and the complexities around having AI systems embedded in organizational infrastructure and the security concerns in the space. And so I would like to just call on Jay to provide some insight on that.
I think the biggest challenge, and we'll probably talk about it in the session after this, is how the entire practice of delivery is evolving. And that means the role that the architect used to play, the role that the design team, and especially the cycle that you normally would go through when you deal with an agile process, all of that is being turned upside down. And I think that is what's changing the work situation almost entirely. Because if your productivity is high, and you know that the code that is being produced is irrisome, or there are security issues or other problems with it, how are you going to stop that from happening if you don't have some kind of reliable mechanism to get this done by? So I think that that separation of how you take your deterministic rules, your existing designs, your architectures, the way that you want to conduct your business that is safe, and deal with the parts that are variable, that can move and can shift over time, that is a new structure that's going to emerge from that. So that means that change in work at the moment is very fluid, because what people are trying to do is to give an existing role additional tooling to achieve an outcome. And it's all, like you were explaining earlier, done in a very fragmented fashion. There is no coordinated way to say, well, we have got now a role that is called the enterprise AI architect, and that role is responsible for creating the rules around the ontology of the industry that you're in and the architecture. And the people that work on that part of the technology delivery are far removed from the people that implement it in variations in the rest of the organization. So I think because of that kind of design means that your classical agile process of coming up with epics and user stories and put it onto your 10-day cycle, it should be, what can I do this hour on a deterministic framework to test anything that a user is going to see or feel. So you should take user story plus the epic that the user story belongs to, and you should be able to create a test in an hour, not in days or weeks anymore. But then to get the user to use it later on, you still have the common practices in place. So I think that messiness of how all of these roles fit together is what's creating a lot of that discomfort.
Definitely, that's quite well said, Jay, when it comes to a lot of the concerns in this space. And one thing that I think it highlights is that if you're working with teams and organizations, for there to be that coherence in using AI models, not only just having the same structural reference is important, but also the implicit understanding over sessions as well is something that should be of value as we go. As architectural systems stay stable and changes happen as well, you want governance that doesn't mean it is slow, but governance that is explicit, and that deterministic spine is the mechanisms that makes every generation traceable, to that each decision, and code bases can become auditable as well. I think that's something we want to focus on as well, that auditability is a feature that is not just a compliance exercise. You want every generated file to be traced back to a UML decision that is visible, that can also be accessible to any stakeholders in the team as well. And so what this can also connect to over time is that regeneration becomes repeatable when that context is externalized. And so if your system is burning down tomorrow and you have to regenerate everything from scratch, what would you generate from, right? What is the answer to that question? Is it just the same structural reference as last time, or do you want to be in a position of resilience where the answer is embedded in your knowledge base as well? And so these are properties that work together to construct the pattern of organizations that survive, not just based on specific tools, not just based on specific models, but have a pattern in terms of their operations. And so what we've talked about today, if it resonates with anyone listening to this, I think this is something that we can definitely discuss even further with questions at the end of the session. But the most useful thing to also do is on our website, we have resources available to guide you and walk you through the steps in the deployment and just the incorporation of ecosystem code at this level, and for you to also be able to see what it looks like to describe a system in general language and watch the UML models generate in real time. And if you want to go deeper as well, we can definitely contact our team. But before we close off, I do want to address some pertinent questions that come in spaces like using AI models within organizations that operate at scale, because what we tend to see is that organizations already have AI tools that they use. And so when it comes to using tools like ecosystem code, there's a lack of understanding of where ecosystem code sits within that developer lifecycle. And I think it's important to understand that ecosystem code is a structural reference tool that governs what each of those external tools generate. And so they're complementary. And in fact, the MCP APIs that you get from a system are specifically designed to integrate with AI coding tools that you want to use. And so they are based on the same architectural context that is available from there. And so from there, you kind of gain an understanding of how to use domain modeling sessions to build from existing legacy systems with no existing architectural documentation. And so the goal here tends to not be perfect architecture diagrams from day one, but rather a shared reference that's better than no reference at all. And so what ecosystem code does is that it helps you build from that incrementally, and you can do this with something that provides value that compounds as your coverage improves. By it being a model agnostic, deterministic spine, it allows for the structural reference to match where the context sits at the moment, where it doesn't care which model reads it, but rather that it determines the quality of the generation. And this is actually one of the strongest arguments at the moment, and where you're not just locked into any model's implicit understanding of your system. We have it off slightly earlier than anticipated, but this is perfect for questions. Sorry, Jay, you wanted to say something?
I was going to say, it's probably just worth mentioning, and we will discuss it in the next session, but that when you have a model that was trained on a very generic set of data points that has got to do with the world's generic knowledge, the cost of reasoning and the cost of the token generation is pretty high if you expect it to do work from scratch every single time. So that's why the deterministic approach with the generative dealing with the variations as a construct helps you, because you can now pick models that are highly specialized. And you will be able to, over time, if you generate something that is mostly to do with real-time systems, offline systems, user interface-based environments, you'll find that coder-based models, including the models that have been fine-tuned by Qwen or DeepSeek, or a lot of these models that are open source, are really good at doing work if you give it a very specific task to do. And that is what we do in the context of that spine, is that it creates not just the prompts that you might want to use externally, but the rules that are there, and it generates an entire enterprise architecture end-to-end for you. And that prepares you for something that's far more reliable than if you had to go do that every single time from scratch.
That is a good point. If there are any questions in relation to this, we're happy to open the floor to those.
So I think the thing maybe to note as well is, in the current ecosystem code environment, the entry point at the moment is kind of wrapped around the domain understanding of the industry that you're in, plus potentially taking whatever the detailed version of a prompt is that you're going to want to give it, but you want to make sure that it is as abstract as possible initially. The work that it does is essentially as a 7-layer approach to go and figure out the domain and the understanding of essentially collecting a broad spectrum knowledge. Kind of, it's almost like throwing an umbrella over a number of different topics until it's figured out what's most relevant to what you need to do. And when it then generates the initial design for you, and I think this is what's missing with most AI tools, is that there is no place where you can put your eyes on a design before work gets done. So it's almost like in the AI world, we've been trying to skip the step. We've been trying to go straight from somebody giving a coding tool a prompt and expecting the code that comes out on the other end to be compliant and adherent to what you want to do. And you have to describe your architecture again and again and eventually turn it into rules or into tasks or whatever the mechanism is that you have in place for your AI tooling. If you have that already done and you do have the scaffolds in place, your generation capabilities are exponentially more accurate and better at producing an output that you can extend, because you can keep on regenerating the core. And that's how the data stays stable, because it knows what the model looks like. If you want the data to change the model, then regenerate, and then you can keep on regenerating it for different targets. So at the moment, we can generate, let's say, the user interface into Vue or React or some front end that that is kind of a modern UI. The middle tier you can generate based on your organizational standards. So it could be C# or Java or Node or Rust or any one of those languages. You can generate the middle tier. And a backend, you can decide if you want to do a SQL or NoSQL database. So you can decide if you want to generate for Microsoft SQL, Postgres, or for NoSQL if you want to do it in, let's say, MongoDB. So that means that ability to combine the layers into some kind of output that is already agreed by your architectural team is something that puts in place that speed of execution. And it also comes with the reliability that you don't have to go re-audit, recheck, check security the whole time, rebuild everything from the ground up, because your deterministic rules are already in place. Our enterprise version, what we will evolve over time, is that core scaffold can be decided on by your organization that is specific to your organization. At the moment, in the ecosystem code public platform, when you generate a platform, it takes a view that it will use practice that is best for the kind of architecture that is being deployed. And that means this separation of user interface, if it's in a browser-based deployment versus the middle tier and the business rules in a database, it takes a view on that, and it then generates that for you. Where in an enterprise, you often have the messiness of, a lot of these components fitting together. The other thing in an enterprise that we're looking at is that if you give it source code as an input, we reverse engineer the design from the source code. You can reapprove your design and then generate out a platform in your target architecture. So if you generate it out headless, and let's say you want to make a data pipeline from an old pipeline to a new one, and you want to target GCP or Azure or AWS or something as your target. So let's say you want to move from on-prem to cloud, you can regenerate a certain application. And we found that what happens in enterprise, especially applications like CRM systems and HR systems and procurement and finance and the like, are often occupied by very expensive tooling that in most cases do not fit the organization. You've over years evolved, based on what the tooling provides. So our go-to regeneration is typically being Salesforce or SAP accounting or one of those kind of public platforms or Workday. We want to regenerate those kinds of applications based on a requirement that you have specifically for your business, rather than having to go through this entire platform redesign. And this is also the story, I think, that's playing out in the market with people like Satya Nadella and others making comments that the world of SaaS and enterprise software is under severe pressure, and it might be the end of its lifetime. Because one of our other go-to generations is Microsoft Dynamics CRM. We regenerate it. It takes about an hour to regenerate a full CRM platform for a target organization. That is changing the landscape significantly. Because if you could take what the world already knows about these tools and create a version that you own and you control, and you want to then update it over time, and as technologies evolve, you just regenerate a new version. But you cannot do that if you use classical generic AI, because it's going to keep on making mistakes. You need something that needs to keep the security, the database connectivity, everything that you know that's stable. You don't want to go through all of the pains that you normally would have to go through when you migrate from one version to another. So that is kind of the problem that we working on in the context of the ecosystem code stack. So I think that the thing about the whole software as a service or platform as a service environment is almost kind of morphing into a construct of intellect as a service in order to deliver a reliable outcome as a service. And we're already seeing that evolution of companies into these new kinds of organizational, structures that sell value as essentially a final outcome. Because the world is permanently in change, it means that what you need to do is to be able to generate something that is relevant to the moment. So if there's an example of new technology being invented, the amount of pain that companies go through to deal with implementation and migrations is an endless challenge. And I think what the SaaS world does, it solved some of that for you. But if you could recreate functionality that was charged as a service, but now you regenerate it and now you're just going to pay for infrastructure, you'll see that we believe that the reason why the global data center business is exploding still is not just because of GPUs by NVIDIA and the like. That's not, we believe, the only reason. The reason is that the software component of the classical licensed product is becoming far more specialized than what we initially thought. Like we have a product in ecosystem AI around our recommenders and our algorithms and the like that we do empirical research on, that is charged as a license because it requires R&D from us continuously to update the behavioral science algorithms. And what the client buys is the comfort that the research that we did and the encapsulation of the capability is something they don't have to do themselves. So the justification for paying for a license fee is that if I can generate this myself, what would it take for me to gain access to the empirical work that was done? Where in classical SaaS systems, there's no real empirical, you don't do empirical research to generate a new accounting system, to generate a new CRM system, a procurement system, a booking system, or whatever it might be. You don't need empirical research for that. So the difference, we believe, in the systems that require human intellectual creative design will probably stay in the license-based model, but most of the rest of the enterprise stack is probably going to go through an entirely new way of thinking about what the possibilities are.